Hello, welcome to video number 63. We're going to talk about some advanced rectangle problems. This is short. We got two examples and then a journal assignment for you. We're going to focus on one type of problem. Actually, the problem you see right here. How to find an area of a rectangle like that when it's kind of slanted in the grid. Well, we got to find the width and the length. That's what we got to do. So here we go. This is our first example. Okay, this kind of steps us through it. We're going to find the length of side AB. That's kind of the length of the triangle. And we're going to find the length of side BC. That's the width. So this one is L. This one's W. So AB, that's kind of the length. And BC, that's the W. Then, once we have those results, we're going to find the area using the formula width times length for rectangles. Now the catch is the width and length, they're probably going to be square roots. So let's go ahead and get started. So to find the length of AB, we're going to do what we did last unit, and it's kind of hard for me to draw, but we're going to make a right triangle. Well, that was pretty bad. This one goes 1, 2, 3, 4, 5, 6 along this side, and 1, 2, 3, 4, 5, 6 along this side. And L takes the role of C, the hypotenuse. Okay, so we're going to do a squared plus b squared equals c squared. We'll use the Pythagorean theorem to find that length, because it's kind of diagonal length. So for a horizontal or vertical, we could count just units. But because it's diagonal, we have a little bit of a problem. So we have 6 squared plus 6 squared is c squared, or 36 plus 36 equals c squared. And that gives me c is the square root of 72. Okay, 36 goes into 72, obviously twice because it's 36 plus 36. So I'm going to simplify this. This is 6 times the square root of 2. Okay, that's the length. All right, let's find the width here. Let's see if I can do a little bit better with the triangle. All right, so we're going to use this right triangle and the Pythagorean theorem. This is 3, and this side is 3. So we can use these two legs to find the width, which is a hypotenuse of the right triangle. So we have c squared, or a squared, plus b squared equals c squared. That's 9 plus 9 is c squared. So we get c squared is 18. So c is the square root of 18. And I could simplify it. 9 and 2. This is the square root of 9 times the square root of 2, which is 3 times the square root of 2. Okay, so 2 square roots. That's all right. We can do this. So to find the area, I have to multiply these. So this is like a little bit of review from our square roots unit. So it's the width, 3 square root of 2, times the length, 6 square root of 2. Now, we did problems like this. This is all multiplication here. We have 4 numbers being multiplied. 3 times 6 is 18. Square root of 2 times square root of 2 is square root of 4. That's just 2. So this is 18 times 2. I finally get 36 after some simplification. Wow, even though I had radical sides, 6 square root 2 and 3 square root 2, the area turned out to be a whole number, 36. Okay, this is a good problem. It involves Pythagorean theorem. It involves simplifying square roots. And it involves multiplying some square root expressions. You know, I love it. All right, here we go. Let's do one more example. And we'll be practicing this in class too. If you really have to, you could find the decimals for the hypotenuse and multiply them. But I really want to see you do the square roots. Okay, so here, let's try this one. First find the length, the width. So that's side AB. So let's make a right triangle here. We see it's 4 and 2 are the legs. And we can find the hypotenuse. So 4 squared plus 2 squared equals c squared. So that's 16 plus 4 equals c squared. Or I guess c squared is 20. So c is square root of 20, and we know we can simplify. C is, let me see, that's 4 and 5, so 2 times the square root of 5. The way I did that was square root of 4 times square root of 5, and square root of 4 becomes 2. Okay, that's the width. Let's find the length. All right, there we go. This side is 1, 2, 3, 4, 5, 6. This one's 3. Okay, 6 squared plus 3 squared is c squared. So 36 plus 9 is c squared, or c squared is 45. So c is square root of 45. Okay, think, what perfect square goes in there? We did so many of these. Hopefully it's becoming automatic to you. We can break it up as square root of 9 times square root of 5. Square root of 9 is 3. So we get c is 3 times square root of 5. Okay, we got our width. We have the length. Let's multiply them. So the area is going to be 2 square root of 5 times 3 square root of 5. Okay, again, 4 things being multiplied together. So we can multiply the whole number of parts. 2 times 3 is 6. And then square root of 5 times square root of 5 is just 5. All right, and so the final answer is 6 times 5, which is 30. Cool, worked out to a whole number again. That doesn't always have to be the case, but it turned out in these two problems. Right, here we go. Time for the journal assignment. Okay, so you're going to have to use the Pythagorean theorem to find the length of side AB, and actually, instead of BC, I see that that's kind of impossible. There is no side BC. So find the length of AB and then AC. The letters got kind of switched. So AC. Then find the area of ABCD. ABCD, the rectangle. Okay? All right. Good luck.